Okay, class, good day. We will tackling about the linear function of the college algebra. Linear function is a function whose graph is a straight line. Linear function can be written in the slope-intercept form of a line. In the formula of x equals mx plus b, where b is the initial or starting value of the function. When input x equals 0 and m is the constant rate of change or slope of the function. The y-intercept is at 0b. A linear function can be represented with an equation, words and table and a graph. A linear function may be increasing, decreasing, or constant. The slope determines if the function is an increasing linear function, a decreasing linear function, or a constant function. In an increasing function, this table 1, and the decreasing function, the table 2, and then the constant function, we're in the table 3. Next is the calculate slope. In the calculate slope, the slope or rate of change of a function, can be calculated according to the following. M equals change in output or means rise equals y equals y sub 2 minus y sub 1 over the change in input, which means run equals x sub 2 and minus x sub 1, where x sub 1 and x sub 2 are input values, y sub 1 and y sub 2 are output values. Next, in the point slope form. In the point slope form of a linear equation, takes the form of y minus y sub 1 equals m, open parenthesis, x minus x sub 1, close parenthesis, where m is the slope, x sub 1 and y sub 1 are the x and y coordinates of a specific point through which the line passes. Example, a line has a two slope of 2 and passes through the point, which means 4 and 1. Y minus 1 equals 2, and then close parenthesis x minus 4 and, close parenthesis. Next is y equals 2x minus 7. That's the one of example.
So good day everyone. So for today we're going to talk about the equation of a line using 2 points. Given 2 points, write the equation of the line. Use the coordinates of 2 points to find the slope. Second, use the slope and 1, the coordinates of 1 point to find the equation for the line. And lastly, simplify to rewrite the equation in slope-intercept form. So let me state an example. Write the equation of a line that passes through 0 and 1 and 3 and 2. In solution, you need to use the slope-intercept form. So m equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2 is equals to 2 minus 1 over 3 minus 0. And the answer is 1, 3. So y1 equals to 1, 3 times x minus 0, or y is equals to 1, 3 x plus 1. So next is a graphing a function by plotting points. First, you need to choose a minimum of two input values. Second, evaluate the function at each input value. Third, use the resulting output values to identify coordinate pairs. Fourth, plot the coordinate pairs on a grid. And lastly, draw a line through the points. Example, graph f times x equals to negative 2 over 3 x plus 5. So the solution at x equals to 3, f times 3 equals to 3, and that's 3 over and 3 to 3. At x equals to 6, if f times 2 6, it equals to 1, and it is plot 6 over 1. Next, graphing a linear function using y-intercept and slope. In the equation, f times x equals to mx plus b. So b is the y-intercept of the graph and indicates the point 0 and b on which the graph crosses the y-axis. M is the slope of the line and indicates the vertical displacement or rise and the horizontal displacement or run between each successive pair of points. Recall the formula for the slope. So m change in output or rise over change in output run equals to y x equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1.
And this time, we will be talking about graphing a linear function using y-intercept and slope. In the equation f of x equals mx plus b, b is the y-intercept of the graph and indicates the point 0, b, at which the graph crosses the y-axis. M, however, is the slope of the line and indicates the vertical displacement or the rise and horizontal displacement or run between each successive pair of points. Now, let's recall the formula for the slope. M equals change in output over change in input, or equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that is our formula for the slope. Now, this time, let's learn how to graph a linear form using transformatives, or transformations, rather. Another option for graphing is to use transformations of the identity function f of x equals x. A function may be transformed by a shift up, down, left, or right. A function may also be transformed using a reflection, stretch, or compression. Now, let's talk about vertical shift. In f of x equals mx plus b, the b acts as the vertical shift, moving the graph up and down without affecting the slope of the line. And notice that adding a value of b to the equation of f of x equals x shift the graph of f a total of b units up if b is positive, and the absolute value of b units down if b is negative. Now, how can we write equations of linear functions? So, for a graph of linear function, find the equation to describe the function. How? This is our first step. Number 1, identify the y-intercept of an equation. Then step number 2, choose 2 points to determine the slope. And step number 3, which is the last step, substitute the y-intercept and slope into the slope-intercept form of a line. Now, let's find out how to find the intercept, the x-intercept of a line. The x-intercept is the x-coordinate of the point where the graph of the function crosses the x-axis. In other words, it is the input value where the output value is 0. To find the x-intercept, set a function equal to 0 and solve for the value of x. For example, consider the function f of x equals 3x minus 6. Then set the function equal to 0 and solve for x. And this is how it goes. 0 equals 3x minus 6. Transpose negative 6 over to the left, which makes it positive 6 equals 3x. Then divide both 6 and 3 to 3, and that will give us x equals 2. The graph of the function crosses the x-axis at the point 2, 0. Now this time, let's talk about horizontal lines. What is it? A horizontal line indicates a constant output or y value. In the figure, as you can see right there, the output has a value of 2 for every input value. The change in outputs between any 2 points, therefore, is 0. A horizontal line is defined by an equation in the form f of x equals b. So that is horizontal lines. Now, how about vertical lines? A vertical line indicates a constant input or x value. We can see that the input value for every point on the line is 2, but the output value varies. A vertical line is a line defined by an equation in the form x equals a. A vertical line has an undefined slope and is not a function.
Parallel and perpendicular lines. Two lines are parallel lines if they do not intersect. The slopes of the lines are the same. F of x equals m sub 1x plus b sub 1 and g of x equals m sub 2x plus b sub 2 are parallel if m sub 1 equals m sub 2. If and only if b sub 1 equals b sub 2 and m sub 1 equals m sub 2, we say the lines coincide. Coincident lines are the same lines. Two lines are perpendicular lines if they intersect at right angles. F of x equals m sub 1x plus b sub 1 and g of x equals m sub 2x plus b sub 2 are perpendicular if m sub 1 and m sub 2 equals negative 1. And so, m sub 2 equals negative 1 over m sub 1. The slope of this one line is the negative reciprocal of the slope of the other line. Perpendicular lines. Given 2 points on a line and a third point. Find the equation of the perpendicular line that passes through the point. First, determine the slope of the line passing through the points. Then, find the negative reciprocal of the slope. Last is use the slope-intercept or point-slope form to write the equation by substituting the known values. Absolute value function. The absolute value function can be defined as a piecewise function. The most significant features of the absolute value graph is the corner point at which the graph changes direction. This point is shown as the origin. Intercept of an absolute value function. Knowing how to solve problems involving absolute value function is useful. For example, we may need to identify numbers or points on a line that are a specified distance from a given reference point. For the formula for an absolute value function, find the horizontal intercept of its graph. First, you have to isolate the absolute value terms. Then, use a equals b to write a equals b or negative a equals b, assuming b is greater than to 0. Third is solving for x.
Building linear models. Given a word problem that includes two pairs of input and output values, use the linear function to solve the problem. First, identify the input and output values. In linear model, the input values are the x values and the output values are the y values. This is because in the linear model, we are trying to predict the output value, which is y, based on the input value, which is x. Second, convert the data to two coordinate pairs. The data is converted to two coordinate pairs x and y, where x is the input and y is the output. Third, find the slope. The slope is calculated by the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This gives the rate of change of the output with respect to the input. Fourth, write the linear model. The linear model is written in the form y equals mx plus b, where m is the slope and b is the y-intercept. This is the equation of a line in slope-intercept form. Fifth, use the model to make a prediction by evaluating the function at a given x value. To make a prediction, substitute the given x value into a linear model and solve for y. This gives the predicted output value. 6. Use the model to identify an x value that results in a given y value. To identify the x value that results in a given y value, substitute the given y value into a linear model and solve for x. This gives the input value that results in a given output value. 7. Answer the question posed. The answer to the question posed is found by substituting the given x value into the linear model and solving for y. This gives the predicted output value. Scatter plot. A scatter plot is a graph of plotted points that may or may not show a relationship between two sets of data. For the example, the final exam scores versus the age. Note, this example scatter plot does not indicate a linear relationship. Points do not appear to follow a trend. There does not appear to be a relationship between the age of the students and the score on the final exam. Interpolation and extrapolation. Different methods of making predictions are used to analyze data. The method of interpolation involves predicting the value inside the domain and or range of the data. The method of extrapolation involves predicting the data outside the domain and or range of the data. Modal breakdown occurs at the point when the model no longer applies. Correlation coefficient. The correlation coefficient R is a value between -1 and 1. R greater than 0 suggests a positive or increasing relationship. R less than 0 suggests a negative or decreasing relationship. The closer the value is to 0, the more scattered the data. And the closer the value is to 1 or -1 is the less scattered the data is.